So I'm Mike Kiernan from Microsoft. So what I want to present today is an internal project that we're doing within my team. So my team's a delivery team. So we deliver HPC clusters for customers. We answer RFPs, tenders, do a lot of benchmarking, that kind of thing. And we also manage clusters for some of our key tenants, like the UK Met Office. So we're busy building all kinds of different infrastructure for different types of end user case. This is a project we started probably 3 or 4 years ago. A lot of the Microsoft colleagues were already using EasyBuild, so we had a sort of another camp within the organization using EasyBuild. I lost my European status when Brexit happened. I was feeling a bit bitter about that, so I decided we were going to go with Spack in my team. So a lot of what I'm going to say you've heard in numerous presentations so far today, and actually that's quite heartening for me coming here. We've been working really in isolation. We haven't been part of the community. We've just been building this as a byproduct of a need we had to create these environments very rapidly. We were getting very tired of installing software by hand. So we wanted to kind of build a standardized, what I'm calling a programming environment. I'm actually questioning that a little bit now, listening to some of the other talks, whether it's a little bit wider than that. But essentially, we found our way to Spack. It solved this combinatorial soup problem. And I'll show you what that means for us in a second. But yeah, we've got lots of different things we need to support. The installs, even with Spack, are still a bit contentious in our team. So occasionally when we're adding a new package, something you have that moment where you're like, I hope this just works. And it turns into a sort of 5, 6, 8 hour marathon trying to install that. So even today I have to encourage my team to stay with it. They know they can do something in 15 minutes, unrolling a tarball and install it manually the way they used to, but we need to keep everybody away from the sort of click ops and get it into the build so that we can keep building on top of that and get the quality that we're looking for. This is quite mature now, the environment that we've created, so it's been running for a couple of years, so we've got a number of different development environments with also a lot of end users consuming that as well, so it's been quite successful for us. The other problem I was trying to solve with this is the out-of-the-box experience. So we got a lot of feedback from customers that were sort of left to their own devices. So we sort of, do the cloud thing, spin up this cluster, and we're all celebrating how quickly that happened. But then when they go into the environment, they're sort of following their nose, doing what they do on their on-prem cluster, assuming all the things are going to work in the same way. They don't. They kind of go off the rails, have a horrible experience. So what we want to do is create a baseline environment that feels familiar to them so they can find themselves very quickly, find their way to the green path, make the right choice of the MPI in particular for the application that they're using. So we're just trying to put together some easy to follow recipes for those customers. Performance reproducibility is something we've talked a lot about in the performance working group, but we have the same problem. This is our solution to that problem. So creating this curated core software environment within which we can run customer benchmarks and applications and have that reproducible on any of our clusters around the world. Time to first science, so getting up and running in Azure, so by having all of those libraries ready there. So we did that before. We have operating system images that we publish in our marketplace. So if you look for a -HPC image in the Azure Marketplace, there's lots of flavors of Linux that we support. We have different teams that are also curating packages into those images, so all the drivers that you need to make that work on Azure, but also a small group of compilers, math libraries, things like that, just to kind of get you up and running. Problem with that is it's sort of a point in time, works at that moment, but 3 weeks, a month later, we're moving on. So what we're trying to do is decouple ourselves from that, have everything in an external Spack repository, and then we have much more flexibility to increment on whatever the customer or the benchmark that we're trying to run needs. One size fits no one. So I'm seeing a lot of these sort of solutions that kind of come up with a manifest of packages and then a script which is going to like run through and install them all. It's not really what we're looking for. We're looking for something much more composable, so we can select up front just what we need and nothing more to create that environment, built with the packages and the best practices that we've developed over time to make sure they have a good experience. Proprietary PEs, that's the strengths and weaknesses to that. I'm not going to go on about, I've got a lot of friends in Cray HPE now, so I don't want to throw rocks, but feedback I get from the customer is that it's just really hard as a scientific software developer to get something done. Like I need a new compiler or I need something new. I have to go and open a ticket, wait God knows how long, and I might end up with not actually what I asked for in the end. With the Spack environments that we're creating for them, they can just chain on top of the sort of curated environment that we're presenting to the end user. They can use Spack chaining. We've heard several other examples of that today, so it seems like that was the right choice. And that's how we're enabling them to just install bespoke packages, whatever they need in their own home directory. The other thing that we struggled a little bit with in the beginning was, and I've heard a lot about inodes. So latency is really important. Heard somebody say that the other day as well. So we've noticed the same. So our general best practice for HPC environments is we'll have an Azure NetApp files cluster, which is an all-flash array, very low latency. That's where we'll put the sort of binary source code, home directories, all the stuff that doesn't need parallel throughput. So that will go on that all-flash array, and then we'll stand up a Lustre file system or something like that as the scratch case for the cluster. So the sort of natural place to put the Spack repository was on the NetApp. So even there where I've got sub-millisecond latencies over the wire from that device into my compute cluster, still with millions of files, it just ends up not being as fast as we would like it to be. So we came up with an interesting solution. We borrowed from the Easy project to do that with CVMFS. So this is our my team's sort of span of control, if you like, at the moment. So there's a typical sort of bunch of clusters that we're having to manage, and we're running these environments on. So we might have in the UK a Cycle Cloud cluster, and Andy from Cycle Cloud team is over here. So we have Cycle Cloud as our main tool that we use for deploying clusters in Azure. So we have a big cluster that we use in the UK for all of our sort of local work. The kind of hardware that we have varies from region to region. So the myth isn't true, cloud is not infinite. We do have to figure out where we have power and space and deploy clusters in particular locations. So in the UK we have a AMD Milan X cluster that we're using with a number of different customers. We use it as one of our benchmarking environments as well. There's a couple of other more exotic SKUs attached to that cluster as well. The next generation of that platform's the Genoa X. That currently we use a system in Sweden. So I need to, in the past I would be copying files around and trying to replicate things across zones. So we've come up with a much slicker way of dealing with that now. We also have dependencies on the US, so the new HB5 clusters, which is our HBM SKU, which is going to be coming out soon. That will require us to push systems into the US and work in that region. Then we have the more exotic stuff with Cray systems. We're also now having to deal with AKS coming along as well. So part of our QA of our environments and benchmarking, we're also testing on AKS. Our AKS clusters also support InfiniBand now. So containerized workloads are becoming more of a business as usual for us as well. You see on the right-hand side, typical types of things that we need to support. So these are all things that we need to stand up in these environments. And luckily, Spack is the tool that really helps us pull all of that together and build out that test matrix. So this is just a high-level glimpse of what we created. This is really the brainchild of Victor and Trevor from my team. Unfortunately, they weren't able to travel here, so I'm just going to give you the high-level view. So a couple of things that we're quite pleased with ourselves that we did here. So CVMFS, as I mentioned, we borrowed from the idea from the EASY project. Hopefully you're familiar with that. One of the problems we found with that is it requires more infrastructure than we wanted to deploy. So you have to deploy CVMFS servers into all of these different VNets in these different regions. So it's more spinning stuff that I have to patch and maintain and deal with security alerts and that kind of thing. So we didn't want to do that. What we want to do is come up with a way of taking a Spack file system and essentially publishing that and then pushing it out into these regions and then mounting it on the cluster. So the way we did that was, so we have our build factory in the UK at the bottom there, so there's a bunch of pipelines driving that. We've published the repository into a blob storage account, so it's like our equivalent of S3. So all the data gets published into there, then we use a tool called the AZ copy to push that out to other regions. We are experimenting with some other distribution methods, but that's the simplest one that we're using internally for now. So that lands into blob storage accounts in all those different regions I mentioned. The nice thing about that type of approach is you can expose that as a $web endpoint. CVMFS, miraculously, the client understands that, so it means I can mount that file system directly onto my HPC cluster from a blob storage account. So that works really, really nicely. It also means we're just paging in the binaries and the libraries that we need onto the NVMe drives. They get cached. So our servers are not diskless. They generally have 2 or more NVMe drives in the compute node. So that comes in quite handy for caching all of these utilities that we're consuming from that Spack file system. In terms of reproducibility, what we're also trying to do is deal with any regressions that might come up. So we've built a sort of, or we're leveraging the versioning capabilities of CVMFS as well. So we can roll back from one curated version of our Spack environment and all the packages we're maintaining to a previous version. And we're releasing those versions at the moment about once a month, and also based on projects and demand that we're getting from customers as well. Final slide. So to summarize really, so our dream was just to not install stuff anymore. We just wanted to install it once in our build environment with Spack, create that frozen file system, and then push that out to our clusters so we can just mount. As soon as we spin up the cluster, it's already mounted it out of blob, and I can see everything that I need to see. So we find that really, really useful. We got rid of our sort of dependency on the packages in the OS. That was quite important as well. So for the most part, we can transport that to new OSs that we're supporting more easily. We've stolen and borrowed some ideas from some other projects. I think there is a lot of overlap with things like Spack Stack. So I think there is a conversation to be had around what are we all trying to do on top of Spack to make it kind of site-specific for our own environment. So I don't know if that's a working group thing. I've had a few offline conversations that there does seem to be some commonality and some interest in this. So come talk to me and I'll buy you a beer. I'd like to get your thoughts and see if we're on the right track here.
Awesome, thanks so much.
Thank you very much.